Good morning, everybody. I hope everyone had a great day yesterday. We're going to start by reviewing page 485. So on page 485. I know some of you reached out to me yesterday worried about making sure you've turned everything in. I'm not talking about if you forgot to send the names one time or two times even. I'm talking about the students who just clicked that submit button with nothing. Though that's who I'm talking about. So don't sweat it. You'll know. I've been in contact with you, and you guys know which if you've been active or not in class. I just want to make sure that you are getting all the information you need. And I want you to do well next year. It's not just about doing work. It's about learning the material and doing well, not being frustrated by it. Number 1, Joshua picked 11 apples, which he shared equally among his 3 friends. We talked about this yesterday. There's really going to be 11 divided by 4 because it's Joshua and his 3 friends. So that'd be 4 people. So because we have more apples than people, we know that our answer is going to be, an improper fraction, which means it's going to be more than 1. That's what improper fractions are. They're more than 1. So we're going to get 2 and 3/4 apples for each person, which is great. It's a lot of apples. It's good for you. Number 2. There are 4 cups of flour. If 7 people are going to share the flour equally, it's an interesting situation here. How much flour will each person get? So here we have 4 cups of flour, and we're breaking it up into 7 groups. We had 11 apples, breaking up into 4 groups. 4 cups of flour, breaking them up into 7 groups. Because we have less flour than people, not everyone's going to get a whole cup, right? It's going to end up with a part of a cup, which is 4/7 of a cup. And you could draw this out, You could be like, here's my 4 cups. If I broke these each into 7 pieces, right? Someone would get one of those, one of those, one of those, and one of those, which would be 4/7. And you could do that. Draw it out. Break it up into 7 pieces. It's good practice. Number 3. Tavon has 15 feet of fabric, which he wants to cut into equally sized pieces to make 8 napkins. How many feet of fabric will he use for each napkin? So here we have 15 divided by 8. Because we have more fabric than pieces or napkins that he wants to use, then we would have a mixed number again. And we'd get 1 7/8. And the answer would be feet. And number 4. There are 4 granola bars to be shared equally among 9 students. All right, so we have our 4 granola bars. We have our 9 students. Because we have more students than granola bars, not everyone's going to get a full granola bar. In fact, they're going to get 4/9 of a granola bar. All right. I'm sure Liam will have something to say about my G bar. All right. And number 5, excuse me. Gets old holding the phone and doing all that. I need a staff. 20 gallons of water was shared equally among 6 families. 20 gallons shared equally among 6 families. More gallons than families. So you guessed it, it's going to be a mixed number. It's going to be more than 1. And in this case, we get 3 and 2/6 of a gallon for each family. All right, let's go to page 486. Turn your books to 486 with me. I'm going to turn my book. And here we're getting into what I've been promising, which is the multiplying of the decimals. So we're going to continue with math lessons next week. I know some of your classes are going to end with new material, but math is not, because I really do want us to get through a few more things before I turn you loose. So if we look on page 480, let's actually go to 487, 487. And let's look at number 3. Here we have 25 times 1 1/100th, 25 times 1/10, 25 times 1, 25 times 10, 25 times 100. So let's just quickly solve this. So if you have your book, you're doing this with us. So here we go. Well, 25 times 1/100th would be 25 hundredths, right? 25 times 1/10 would be 2 5/10. You're like, this one's an easy one. It's 25. And this one, if you know the trick with the 0, 1 times 25 is 25. And you just count up your zeros. Same thing here. And we have 2 zeros. So we have 25, 250, 2,500. What I want you to focus on is, how are these two problems related? And those problems are 25 times 1 and 25 times 10. How are those two problems related? If you want to, you can pause the video here. So maybe some of you said, well, 25 is a factor of both problems. That is true. 25 is a factor in both problems. And some of you said, well, 10 is 10 times as great as 1. 10 is 10 times as great as 1. So if we get the answer of 25 here, this answer, because 10 is 10 times the amount of 1, the answer would be over here, 10 times greater than this. So what's 10 times 225? It's 250. And that would be correct too. So there's some ways that everything's related, right? And if we go back up here, 10 times 10 is 100, so this answer times 10 would be this answer. So does that relate to with the decimals? Is this 10 times as great as this? And what I'm asking is 1/100th and 1/10, right? How are they related? Is 1/10 10 times as great as 1/100th? And the answer it is yes. And that's why each of these, if you multiplied them by 10, they would keep increasing. So when we take this 2500 and we multiply it by 10, that's where we get that 2 5/10. It makes that jump over the decimal into the whole numbers. So when you're multiplying by 10, it's pretty easy because you're really just doing the multiplying by 1 and then counting how many zeros there are. So if there's 1 0 for 10, that makes it very simple, such as this. 1 times 25 is 25. I count up my zeros. It's 1 0, you get 10. So how do we use a lot of this with multiplying decimals? So let's start there. So if I have a decimal such as 25 hundredths, and I am multiplying it by 5. Let's start there. 5 times 5 is 25. So what if you notice, I'm sorry for the glare, what you're noticing is I'm going to treat this just as a regular multiplication problem. I'm ignoring the decimal right now. I'm not touching that decimal. So I just set it up like a regular multiplication problem. Yes, I have the decimal there, but it's really I'm not concerned about it at the moment. So I start off 5 times 5 is 25. I put my 5, I carry my 2. 5 times 2 is 10. And we know that in real life, this is not 5 times 2, this is 5 times 20. 5 times 2 is 10, plus 2 is 12. And I say in real life because when we're saying it to ourselves and we're doing it, we're cutting some corners. We're not using all of our words. I would say 5 times 5 is 25. I put the 5, I carry my 2 groups of 10, which is 20. 5 times 20 is 100, right? There's another 2 groups. So I just want to bring that out because I know that if we have our math coordinator watching this, she's going to be like, well, it's not really 5 times 2. And she's right, it's not. We just kind of cut corners when we say it out loud. Let's get back to the problem. All right, so there's no other place value here, so we are done essentially with our multiplication. The question comes in is, what do we do with our decimal? So we're going to count up how many digits there are behind the decimal. There's 1, 2. There's 2 digits here. Are there any digits here behind the decimal? Nope, there's 0. So there's 2 digits altogether behind the decimal, and we're going to start here, and we're going to go 1, 2. So our answer is going to be 1 and 25 hundredths. Remember, we did 25 hundredths times 5. And if you added it up, you sat here and you said, hey, what's 25 hundredths plus 25 hundredths plus 25 hundredths? All right, you would get the same answer. You'd get this 1 and 25 hundredths. We're going to do more of this, okay? And yes, we are going to do some math videos next week. So yes, there will be math work next week. Our 2 students of the day, and I know I didn't say one earlier in the video, but I'll say them both back to back because they're always hanging out in class anyway. It is Carson and Riley. Carson and Riley. You guys have a great day.